Hello class, we are going to talk about compound probability today. And so compound probability, compound usually means there's two things happening. So compound probability is when there's two or more events that are occurring. And we can talk about this in two ways. Either we want something to happen and something else to happen, or the other option is that we have something happen or something happen, one or the other, but not necessarily both. And we've already talked a little bit about the words and or in this unit. The word and means to multiply, and that's going to be true for this section as well. And the word or means to add. And I said that right below this as well. So, and probability problems is what we're going to start with, and means to multiply. So, and implies we want both events to occur, not either or. And then this can happen in two ways, either with independent events and dependent events. So let's talk about the difference. An independent event is that one event is going to have no effect on the other event. This could look like if I flip a coin and then roll a dice. Obviously, flipping the coin has nothing to do with rolling the dice. But another situation, which we're going to talk about a little bit more in depth, is selecting cards. If I select a card, the probability of getting a certain one will not be affected if I then replace and then do it again. So this is with replacement, we call it, okay? So here's our first example. It says you select a card from a standard deck, replace it, and then select another card. So now, since we're replacing it, we start over. So they don't really depend on each other. They're independent events. So the probability of getting a face card and then an ace. And this is an and problem, so I am going to multiply. So the probability I get a face card, there's 12 face cards in the deck, there's 52 cards in the deck, times the ace, there's 4 aces in the deck out of 52 cards in the deck. And again, the reason why I start over for the ace is because I've replaced the first card, okay? And we can go ahead and multiply these together. So 12 out of 52 times 4 out of 52. And we're going to turn that into a fraction. So 3 out of 169. It's like a 1.7% chance. It would be very rare. I mean, we want this exact situation to happen, to get a face card and then an ace. So it's not a very common situation. So it makes sense that it's a low percentage or a low probability. The second example says, find the probability that we get a heart and then we get another heart. Again, with replacement. So the probability that I get one heart, and then I'm going to multiply that because it's the word and by the probability that I get a heart again. Okay. Probability that I get a heart is going to be 13 out of 52 because there's 13 hearts in a standard deck of cards. And again, 13 out of 52. So you can see I'm typing it into my calculator. 13 out of 52 times 13 out of 52. And that is a 1/16 probability. About 6% chance, a little bit higher, that this occurs. All right, I'm going to skip example C. You can take a look at my answer key for that, just to keep this video in a timely manner. But then this one's a little bit harder. It says compare and contrast. What if you're selecting two cards at the same time? And that's different. That's different. If I'm selecting two cards at the same time, it says select that you're going to, or find the probability that you're going to select two 10s at the same time. So if I'm selecting two items at the same time, that's when we have to use combinations. So I'm choosing two cards from 52, and I want to select a 10 and a 10. So how many 10s are there? There's 4 10s. I'm going to choose 2 of them. So I actually don't have to do compound probability for this problem. So I'm just trying to show you that there is a difference between doing a 1 draw, replacing, and then doing a second draw. Those are 2 separate events, whereas this is 1 event happening. I'm taking 2 cards at the exact same time. So that's just 1 event that's happening. And so this is something that we've done previously, but I don't want you guys to get confused when we're doing problems and we're mixing them all together. If I'm selecting 2 cards at the same time, it's 1 event. So we go back to this 4, choose 2, over 52, choose 2. So let's calculate this one. Okay, so from 4 10s, I want to choose 2 of them at the same time. And the total number of outcomes is 52, choose 2, because I'm choosing 2 cards from 52. So 52, choose 2. Okay. So 1 out of 100, or 1 out of 221. So I really wanted to talk about the difference between those. Great. Let's talk about dependent events. Dependent events. Dependent events are when one does affect the other. So for example, if I select a card and then I don't replace it, then the probability is totally going to change for the second selection. So let's talk about that. And the formula looks like this. It's the probability that the first event happens times the probability. Now this is weird. It says B following A. That just means that we gotta kind of slightly change this probability because the first one has affected it. It'll make more sense when we do this example. So example 2 says you select a card from a standard deck, you do not replace it, and then you select another. So for this one, it's the probability that I select a 7, which is going to be 4 out of 52, because there's 4 7s in the deck. All right, and then an ace. But here's the thing. There's 4 aces in the deck, but there's no longer 52 cards in the deck because I have not replaced the first card. There's 51. So that's what I mean by B following A. It's the probability of this event after the first event occurs, which means that denominator is going to slightly change. So that is what the following thing means. And so now let's find this probability. So 4 out of 52 is the probability that I get a 7. Oops, 4 over 52. Oh my goodness. All right, times probability that I get an ace. Well, there's 4 aces left in the deck, but there's only 51 cards left in the deck. And so that is 4 out of 663. Let's do one more example to make sure we really understand this. Probability that I get a spade and then a spade, again, without replacement. So the probability that I get a spade times, again, the probability that I get a spade. But the probability of the second one's going to slightly change. Probability that I get the first spade is 13. There's 13 spades in the deck out of the total 52. Now imagine I'm holding a spade in my hand. There's actually only going to be 12 spades left in the deck. So that numerator has now changed. And there's also only 51 cards left in the deck. So that denominator changes again. Okay, so you really have to think about, okay, if I'm holding this in my hand, then how does that affect the second probability? And then that's it. Let's multiply that out. 13 over 52 times 12 over 52. And turn it into a fraction. Final, delete. There we go. 3 out of 52 is the final answer. Beautiful. All right, I will let you guys try C on your own. The answer key has the answer. All right, I'm sorry, I was thinking, let's do part D. So it says, what is the probability that, I think that I have a typo here. Well, 3 cards, you get dealt in order a red card, a spade, and then another red card. So we want the probability that we get a red and a spade and another red. But we're being dealt cards. So when you deal cards, you don't replace. So all these probabilities are going to be slightly different. So the probability I get a red card first is, well, there's 26 red cards in the deck out of 52. All right, there's only 51 cards in a deck, so I'm getting dealt 3 in a row, okay? So the spade is black, so we don't have to worry about any overlap. There's 13 spades in the deck, but there is only 51 cards left, and then another red card, so be careful. I already have 1 red card, which means there's 25 red cards left and only 50 cards total left. And so that is how you do this one. And let's go ahead and calculate that. 26 out of 52 times 13 out of 51 times 25 out of 50. 13 out of 204. I wasn't planning on doing this problem, but I do think it's a good one to think about. Okay. Let's quickly talk about the OR problems. So the OR problems in probability mean to add. So it's either event could occur, one or the other. It does not have to be both happening, which is an AND problem. We want them both to occur. OR implies we want one or the other. So this can happen in 2 ways, with exclusive or inclusive events. Exclusive means that they have no common outcomes. So for example, if I want to select an ace or a king from a deck of cards, those are 2 different cards, there's no overlap. But an example of inclusive is if I want to select a red card or a queen. The problem with that is that in the red cards there are 2 queens, so there's overlap there. So there's inclusive cards. So let's just do one example of each and then we'll call it a day on this video. All right, so the first one for exclusive events, meaning one doesn't have anything to do with the other. It says 1 card is selected from a standard deck of cards. Find the following probabilities. The probability that I get an ace or a king. The word or implies addition. Probability of ace plus probability of king. Okay, so there's 4 aces in the deck. There's 52 total cards. 4 kings in the deck. 52 total cards. So I get 8 over 52. And let's see, that does reduce. 8 over 52 reduces to 2 over 13. So that is an example of an OR problem. And that is exclusive events. There's no overlap. Inclusive events have a common outcome. So this example says the probability that I get a red card or a queen. So it's the probability that I get a red plus the probability that I get a queen, but I have to subtract the intersection, which we've talked, the intersection, in other words, the overlap. So I want to subtract the probability of getting a red queen. Red and queen. So what I mean by that is this. There's 26 red cards in the deck out of 52. There's 4 queens in the deck out of 52. But we already counted 2 of the queens in here. So some kids say, well, couldn't then we just do 2 out of 52? You could do it that way. That's essentially what we're going to do. What I'm doing here is just the formula, which means you subtract out the overlap. So I need to now subtract the 2 queens I already originally counted out of 52. So we get 26 plus 4 is 30, minus 2 is 28 out of 52. And 28 out of 52 reduces to 7 over 13. So we just subtract out any overlap that occurs, or we have to account for the overlap in some way. All right, so that is a gist of the notes. There are practice problems to do. I certainly want you guys to take a look at my answer key to answer those and make sure you fully understand. But that's it for the video. And that is it for compound probability. Thanks, guys.